So good morning guys. Today we'll be continuing from where we left off in the video classes, right? And I think I have given a proper idea of doing problems, right, of lenses, right? So today we'll be start with a new topic from the lenses itself, that is combination of lenses. We have done some questions regarding combination of mirrors, right? Similarly, combination of lenses is something which is present in your NCERT as it is, right, as a topic itself, right? But in the case that is combination of mirrors as a topic is not there in your NCERT, but problems may come, right? So first, when there are two lenses, like say like this, and they are very close to each other, right? Let's say this one is having focus f1 and this is having focus f2. Then it is stated that the equivalent force of these two, or the system of two lenses, is equal to 1 by f1 plus 1 by f2. This, if there are multiple lenses, it will be 1 by f1 plus 1 by f2 plus goes on, right? So when two lenses, thin lenses, right, when two thin lenses are kept contact with each other or combined to form a system, then the 1 by f equivalent is equal to 1 by f1 plus 1 by f2. Simple, right? Now we are going to derive this equation. How can we derive it? So just like the previous cases, we are going to draw two lenses, right? So straight their axis, right? Let's say I'm going to keep the object O here, so the incident ray goes like this, right? Then it will little bit converge, right? Then it passes like this, reach the second, right? Clear? And then see, if this first was not there, if this two second lens was not there, then this line would have passed, that is of this one would have passed like this, right? And it would have made an image log I dash, right? I hope this is understandable, right? If you want, I will change the drawing to make you guys understand in a simpler way. See, this one, let's say, bending like this, right? If this lens was not this one, this would have followed the path like this and reaches here and makes an image I dash, right? But this image is not seen because of the presence of the second lens, because this line, right, which you are seeing here, this line, after it reaches the second lens, it again double converges, right? Converges the second time, and the image is formed here, that is I, and we see this image I, not the I dash, because I dash acts as an object for the second lens. This is our first lens and this is our second lens, so I dash acts as the object for second lens. Just like in the case of two mirrors, remember, when there are two mirrors, the image of the first mirror acts as the object for the second mirror, right? Clear? Now this much is clear, I hope. We have drawn some figures. Let's say this is I. Now we have to mark the U and V. Obviously this entire system's optics center will be here, right? So the object distance U is from here, right? Clear? And this will be the incident ray direction, and I always measure the optic center from the optic center now measurement, so U will be negative, right? So I'm just telling you the idea of it, how which and all have to be taken positive and negative, right? So this is U. Let's mark it as U. Simple. Now first lens. Let's talk about first lens, right? Image is at I dash, so let's say from optic center this distance is, let's say, is V dash. The image, it's not the original image, right? Original image distance is from I, right? So this is V. Clear? So here I will write 1 by f1, right, is equal to 1 by V minus 1 by U, right? So here it is V dash, 1 by V dash minus 1 by U, right? That is our first equation, right? Now this is the exact way in which your textbook is derived, okay? In the second case of the lens, there the focus is 1 by f2. Here In the second lens, the image is formed at V and the object is what? Our I dash. So its distance from O is P dash. So this is our second equation. Just add these two equations. What will happen? I can write 1 by F1 plus 1 by F2 is equal to 1 by V dash minus 1 by U plus 1 by V minus 1 by V dash. Right. So I can cancel 1 by V dash. So I can write 1 by F plus 1 by F2. Sorry, F1. 1 by F2 is equal to 1 by V minus 1 by U. Right. This 1 by V minus 1 by U represents the focus of the equivalent focus, right? Because U is the object for instance for these two combined lenses, and V is the image formed due to the both the lenses. So 1 by V minus 1 by U can be written as 1 by F equivalent. That is the total focus of the system. It is 1 by F1. I can write now 1 by F1 plus 1 by F2 is equal to 1 by Fe. Clear? Right. Now the next topic we are going to do is called power of optical instruments. All here we'll deal with lens. That is better because we have learned much about lens. Right. So we'll learn about what? Lens. Now what do you mean by power? Power is for any optical instrument. Power means its ability to converge or diverge the path of light. Right, the light, if it is coming, how much amount of light can be converged? That gives you the power of this lens, and how many light rays can be diverged by a lens gives you the idea about the power of the lens. Right, now you have to by heart the formula for power is 1 by focal length, or P is equal to 1 by F in the case of lens. Right, and you know what is a focus length unit? It is in meter. Usually it is centimeter, but that is SI units itself. That is form of meter. And power's unit is either meter raised to -1 or it is diopter. Okay, I will write here diopter. Ouch. No place, huh? Diopter. Right, or it is just written as simple T, capitally. Okay. Right, so we know for a convex lens the focus is positive, right? Then the power will be also positive, right? Whereas in the case of concave lens the focus is negative, that is the power will be negative. Keep this and all things very important, right? Clear? Now the power is there for what? Our next or the initial topic which we have learned is mirror, right? So in the case of mirrors, the power is equal to it becomes -1 by F. It is not +1 by F but -n by F. Clear? So in case of lens it is +1 by F, and case of mirror it is -1 by F. Right? So here also there are two mirrors, concave and convex mirror. Right, and concave mirror we know focus is negative, so power will be what? Opposite of it, that is positive, and focus is positive in the case of convex mirror, then the power will be negative. This is also some point which you have to keep in mind. Okay, good to go. Right, now we'll go for the next section. Right, so that is in the case of power, there is only one more topic, that is combination of lenses. We know when combination of lenses. Okay, so when there are two focal lengths, right, of two lenses and they are combined, I know that 1 by Fe is equal to 1 by F1 plus 1 by F2. Now I can rewrite this equation. 1 by Fe is power equivalent 1 by F1, power of the first lens plus power of the second lens. So power is equivalent power is just equal to the sum of individual lenses power. Right, simple. Right, this and all are your CBSE board topics. Now I'm going to take the topic which is not in your CBSE but NEET, and that's why we are not going to learn the derivation part. We are going to just learn the results. Suppose this is our lens, right, and we are breaking it vertically, right? Suppose this lens is what, f focal length. When I split it, it becomes two focal lengths like this, and each piece will have a focal length of 2f, that is double of this focal length. Keep that in mind, just by heart it. When I split it in vertical section, each of them will have double focal length. That is, if the focus here is 15 centimeter, then this piece will have 30 centimeter focal length, and this piece also will have 30 centimeter focal length. Samajh mein aaya? Okay. Now similarly, if I cut this lens horizontally like this, so I will get a two piece like this, right? Each, if this lens is having focus f, then each pieces will act as, even if it acts as two individual lenses, each will have focus f, right? Clear? Now similarly, another concept questions which comes is, if one surface is silvered, that is, this is a lens and this surface is silvered, so that means you can say this is a combination of one lens and a concave mirror, right? Clear? That is convex lens and a concave mirror, right? So keep this in mind. When a lens and mirror is combined, the overall characteristic is of that of a mirror, right? So that's it. That means if lens and mirror comes up, then mirror is the hero. So the total characteristic of this combination is that of a mirror. Clear? That means, what is the characteristic of this mirror? What type of mirror it is? It is a converging mirror, right? So this will be acting as a converging section, right? Means mirror cannot be said to be converging, but I am just telling you. Okay, so equivalent equation should be there, right? There are two parts. There is focal length of lens is there, focal length of mirror is there, right? So write down the equation 1 by Fv, that is equivalent focus of the system is equal to 1 by Fm, that is 1 by focal length of mirror minus 2 by focal length of lens. Need not by heart the derivation, you need not require it, right? And you know, in the case of concave mirror, Fm is what? Negative. And in the case of convex mirror, Fm is positive. This is for concave, this is for convex, right? This is all that I have taken, or you guys can understand by yourself by doing a lot of problems, right? Now let's do a small problem, guys. Let's say you're having a system like this. Clear? There is a concave lens, and then you are having a converging lens, right? Sorry, this is concave, this is convex, okay, right? And there is a combination, there is a mirror also, right? So how many refracting surfaces are there? 1, 2, 3, right? Keep that in mind. Oh, did I rub something which is very important? No, it's okay. Let's say this is the object, and the object is at a distance 10 centimeter from this surface, right? So this surface acts as this part of the top part of the concave lens acts as the first surface of incidence. So let's say this, let's not name it R1, let's write it as just R is given as 10 centimeter. This side, this surface R is given as 10 centimeter again, and let's say the mirrors R is given as 20 centimeter, right? Now this lens material is having refractive index 3 by 2. This lens is having the refractive index 10 is equal to 3 by 8, right? Clear? This and all are the parameters given. This is a concave mirror, sorry, concave lens. This is convex lens, and there is a concave mirror, right? Clear? You're asked what will be the final position of the image, right? So we are going to remove some of the things because that is not required, because I hope you understood what it is. Okay, so how can I write? I can split this diagram into 3 parts, right? So it's a combination of a concave lens, then a convex lens, then a concave mirror. Let's not deal about how it is going to diverge. We are told that the incident ray will be coming. Obviously, this will be the end result, right? And it goes out. It's just we are not going to how it is diverge, etc. because that much detail is not required. Let's name this as three mirrors. Let's say this is L1, this is L2, and this is L3. Even if it is not lens. Clear? Now we know the equivalent power PE will be P of lens, because once it has passed here, plus P of what? This is another lens, let's say L1, this is L2, plus then it reaches mirror, then the power of mirror, right? Plus again, then after here it is again passing through this, that is the image which is formed or formed after the each lens will become the object for the other, right? So after the light has reached our mirror, again it is getting reflected back, right? So each section is acting as a or each image after the mirror is acting as the object for these two guys. So these two guys participate again. So there is a power from L2 again, and then power of L1. I hope you understood, right? Because the refraction is happening how many times? 1, 2, then it reached, then 3, then 4. Clear? Right, so how that many times the power of converging and diverging happening, right? So then I am going to write it as, see, I told you if there is a combination of lenses and mirror, this entire system acts as a mirror. So there is only one mirror, this is a concave mirror, and I told you in the case of concave mirror the FM is negative or the focus is negative. So equivalent focus will be also negative. This much clear? Then I will write 1 by FL1, 1 by FL2 plus 1 by, right? I told you in mirror what will be the focus, right? What will be the focus? I told you it is what? See guys, what was the relationship between power and focus, right? I'm just going to write here, then I will rub it off. Okay, let's say I'm writing here. We told about power of mirror is equal to 1 by Fm with a minus sign. So what will be, right? This is the substitution for power for mirror. So I'm going to substitute here. So it will become minus Fm. Clear? Right? For any concave lens or convex lens, you have to keep this in mind. Okay. Now the equation is not completed. So again there is 1 by FL2 plus 1 by FL1. Right? Clear? Now we are going to take each piece is different now. Let us say we are going to consider lens 1, which is a concave lens. Right? So for concave lens, 1 by FL1, right, is equal to, it is what? From air to our medium. So it is N2 by N1 becomes 3 by 2 by 1 minus 1 by R1, right? 1 by R1, let's write as 1 by R2 itself, because I have to explain the thing in the diagram. See, this is the surface, right? And the light ray is coming, right? So then it passes this the lens, right? So I'm going to mark this, okay, right. This in this case is R1 and this in this case is R2. Clear? Right. Now when I measure R1, right, see, from this is the if this is the, this will become the optic center of the system. So from here I will make the measurement for R1, and the incident ray is in this direction, right? So R1 will become negative, right? I have to remove this one, or I will not be able to draw that for other section. Now, so here this is 3 by 2 minus 1 is, you will be getting as what? 1.5, that is 1 by 2, right? And 1 by R1, that becomes minus 10. Yes, why? This is the lens, right? And this is the distance measured for R1, right? And the incident ray is in this direction. So minus R1, that R1 is given as minus, sorry, 10. Minus 1 by R2. See, for its surface, this is the direction, because the center will be here for this part, right? And the incident ray is in this direction, and I am taking measurement from optic center like this, so that it is positive. So it is R2 is 10. Clear? Now going on, 1 by, then the calculation please do it. I'm not going to, I'm reducing the steps, guys. So you will get the focus of first lens as minus 10 centimeter, right? Not enough. Again I have to consider our what, convex lens, right? And the convex lens, this surface becomes R1 and this surface becomes R2. This is given as 10 centimeter, this is given as what, 20 centimeter. This is the incident ray, and this R1 surface center lies here, right? So I will measure from the optic center in this direction only, right? So optic center direction from till R2, sorry, R1, or this C1, which gives the direction for R1. Both of the directions are same, so I will take R1 as positive, right? Now let's remove that one and we'll talk about R2. Now R2's spherical sphere surface center lies here, right? That is, here it will be the optic center, and I am supposed to measure R2 here in this direction, and I just told you the incident ray is in this direction, so R2 will be negative. So this will be minus 20 and this will be plus 10. Keep that in mind, right? Clear? Now then again, guys, after this lens is passed, obviously there is a mirror, but at the end the light is in the perspective of our lens, the light rays coming from the lens to outside air, right? So I will write F equivalent for L2, or L2 is equal to N2 by N1. That is, what is the mirror, from where it is going, this one, right? So it becomes 4 by 3. Its refracting index is given as 4 by 3 minus 1, this 1 by air, that is 1 by 10 minus 20, right? You will get FL2 as 20 centimeter, right? And the case of just our what, concave mirror, the last one, this is the hero, right? We know this will be the radius of curvature here, and this will be focus F1, right? That is, F1 is equal to half of R2, R by 2, and you are told this circumference, this one is having radius of curvature as 20, so it becomes 20 by 2, right? Now again the measurement, this is the incident ray, this is the measurement direction, so it is minus 20 by 2, that is minus 10 centimeter, right? Now just have to add the things which you have got. You have written in the equation earlier, 1 by Fe is equal to 1 by FL1 plus 1 by FL2 plus minus 1 by Fm plus 1 by FL1, sorry, FL2 plus 1 by FL1, right? Now substitute the values, guys. That is 1 by Fe, 1 by FL1 is minus 1 by 10 plus 1 by 20 plus minus 10 plus 1 by 20 minus 1 by 10. So this cancels out. No, not that is not cancelled. I can cancel this one. This one and this one can be cancelled, right? Clear? Then there is 1 by 20, 1 by 20, that becomes 2 by 20. That is 1 by 10 minus 1 by 10. That is, I will get 1 by Fe is equal to 0. That means Fe is equal to infinity. That is, the focal point or focal length of this entire system of lenses and mirror is having infinity as its focal length. Clear? Type B. Now let's move on to the next section, which is optical instruments. Optical instruments. Right, that is, what and all instruments are dealing with light is known as optical instruments. There actually 3 are studied. One is human eye, and then it is microscope. Microscope itself is divided into simple and compound, right? And then there is telescope, right? And the eye section we are going to take it, right? And now before I talk about eye, there is a section which is dealing with biology of eye, what and all are the parts of the eyes. Please learn it by yourself, right? It is pure theory. What and all are the parts of eyes, retina, eyeball section, ciliary muscles, rods, horns, etc. Okay, so please study that part, or I request you guys to do that as a homework. Not request, I am asking you guys to do it as homework and submit it. I want to see you guys do it and send me as WhatsApp. Let me see. Okay, and I will tell the same to Smisha ma'am also, that I ask you guys to write some notes as the homework. Okay, excuse me. Right, now what we are going to do is we are going to do or learn how image is formed in the eye. Image formation by eye. Okay, simple. That is, suppose this is our eye, right? Let's take this as a box. I'm just making you guys understand. And this is object. Okay, so this object will be incident some rays over here, right? Or let's make this like this. Image, let's say, is forming here, right? Before that, let's change the direction. Let's say here it is formed and the image has been formed here, right? So I will say it is, of course it is curved, but let's say the image will be in this direction, right? This is AB and this will be A dash B dash. That means the image is inverse. But when I see you, I don't see your legs above and head down. I just see you as you are, right? That means I get an erect image, not an real and inverted image, right? So that is done by what is known as our brain, right? That is, the signals which is received by or from the eyes is inverted in brain, so that now the image in brain will look like AB, right? And this is helped with some eyes parts which is known as rods and cones, helps in a brain in this inversion, clear, or correction of image, right? And similarly, the part of eyes which helps in vision is called ciliary muscles. Ouch. Ciliary muscles, very important, right? Because the ciliary muscles can expand and contract, and help of this we can adjust the focal length of eye, because in all the entire world's lenses, the eyes lens are those which can change its focal length without what rupturing, right? But obviously it should not be strained more. That's why you are asked to not to look at your mobile for a lot of hours, because it causes harm to your eyes, because your ciliary muscles will be continuously giving work. Okay, now let's move on to what happens, some of the introductory part of functioning of your eyes, right? See, when a very far object wants to be seen, right? I want to see a very far object. We know that we will be keeping, that is using a lens, right? Not your eyes. Suppose a lens is used for seeing, or an image has to be formed of an object which is at a very far distance, right? So the image will be also formed accordingly. That is, if the object is moved accordingly, if the object is moved accordingly, the image distance also changes, right? But you see some person is moving before you, he's very close to you, then he's moving far away, right? Yet you are seeing the image. That is, you can be sure that the focal length is always same, or I can say the focal length is still at retina. That is where your image is formed in your eye, right? So whatever the object distance is there, the image distance is always constant, right? Right, that is, in our eye, the convex lens which is present is adjustable, but the focal length can be changed. Clear? I hope you understood. Now, let's see when we are going to deal with an object which is very far, right? And I talk about it. Let's say, see, the eye which I will be drawing, it doesn't look like in any way, but hope to understand. See, this is our cornea. I meant the cornea, okay? So let's say the object is from far away, means obviously the light rays will look like parallel, right? And we know If this is a of course it is a convex lens, so it will be converging, and it is just like lens lines are coming from infinity, right? So points will meet here, right? This is how it functions. That is, the lens will adjust or the ciliary muscles will relax, right? That is, see, I want to see an object that you do actually. That is, you want to see in a far object. You squint your eyes, right? When you squint the eyes, what you're seeing doing is you are expanding the ciliary muscles. So that is, you will see that you want to no expand the lens's area so that all the light rays from the distant object falls through your eyeball, right? And that is, the lens will get stretched, right? Or I can say thickened, right? And the focal length is increased. That is, when the far away object comes and the light rays falls on your cornea, the cilia muscles will relax, thus the lens gets stretched or thickening, right? And the focal length increases, right? For a distance, so that the focal length is such a way that it is always at f itself. That is, the image will be formed at f itself. Clear? Right? And maximum focal length which can be observed for any eye is at retina itself, always at retina, right? And you know, when for a convex lens object is at infinity, the image will be at f, right? Should I thicken the brush? It's better now. Now what happens? The object is closer, right? Where we can see an object before that. Okay, before we talk about closest object, is it okay? I will talk about it. When you having close subject or object, the same eye, right? The object is very close to you, right? So that means what will the ciliary muscle do? It will contract. See, that's like you are using a torch on your eyes, right? So the ciliary muscles will what? Contract, right? It will contract means the lens is getting shrinked, right? I hope you understood, right? Even if you see that when you put a torch on before your eyes, you will see the pupils are dilating. That's different. Pupils will obviously dilate, but I'm telling about the stretching of the lens. Right? The lens will get less stretch, or it will start to contract, right? That means the pupillary or pupils will get wider, right? That's what happens, right? And then again the light rays will be made to fall what? On focus itself. Clear? Now before we talk about the entire things, other terminologies has to be dealt with regarding this, right? So the first terminology which you have to know is least distance of distinct vision, or it is also known as near point, right? Least distance of distinct vision or near point. That is, what do you mean by least distance? Or the word itself gives the proper idea what it means, right? See, this is your eye, right? And you want to see an object, right? So there is a particular distance, right? Between that or after that, of course, I can see the distance or that object. But if that object, let's say the distance is normally it is 25 meter for a normal average healthy human being. So if the distance is 25 meter and I kept an object at 25 meter, obviously I will be able to see this object distinctively. But if I keep the same object before 25 meters, so let's say it is at 20 meter away from my eye, that means I will not be able to see that object clearly, or I can say distinctively, right? So distance for which the eye lens can focus the light on the retina, or I can say that such objects can be, or any object can be distinctively seen in a minimum distance, that is known as least distance of distinct vision. Clear? Right. And the second term which we have to learn is apparent size, right? This is our eye, right? Right. This, let's say, taking an axis, and this is our lens, right? So this is you, right? So or you or some or any person you are intending to look at, right? So there is an angle like this, right? So the size of the object will be this one. That is, this is the size of the man you are visioning, but for you, the man will be, or man's image will be here. Clear? Right? Because image forms at this focal point. So this is the image of the person, or you might be seeing the person as like this. Clear? Right? This will be the, so that is, I am not getting the actual size of the person in my eye. The proposition and the image sizing etc is done in the, in the case of what, usually in the brain, right? So this is how the eye works, right? And this means I am not able to see actual size of the human being. I saw an apparent size of the human being, right? The image which is formed in the eyes is known as apparent size, right? And this is an angle subtended by the object, right? And the angle subjected by the object on the eye is known as what? Visual angle. This is our third name, that is visual angle, the angle made by an object on eye. Clear? And see, suppose I am going to keep this person very, very far away, right? Suppose this person is here and your eye is here. So let's say the ground section like this. So the light ray will be here, right? So this will be the angle, right, has been reduced, right? I can say the visual angle has reduced for, let's say, this theta dash, this log, and this becomes a size, right? That is, I am not able to say the person's size. Suppose the person is 20 meter, I will be seeing only 1 meter as his image. See, that is what happens when you see you are at a larger distance and you are looking at a crowd which is very far away. You will see them as very, very small what images only. You are not able to see the entire person's image, right? So this is how it is happening. That is, always you are not getting an actual image of the object. It is usually apparent image. Most of the, that is when it is least distinct vision, right? This is your eye and this is 25 meter. If the object is in this size, so image formed will be giving, that is, if this object is 20 meter, the image will be also quite close to 20 meter, and even if it is not able to be seen in the eye, it will be corrected in brain. But this type of section, that is the large distances, object's image will be seen as small in your eye as well as in your brain. Clear? But brain will analyze that the object is far away. Clear? Now the topic which we are going to deal is defect of vision. Defect of vision, right? That is, what and all can be faults in your eye, right? The first one which you are learning is myopia, which almost all the youngsters, not all the youngsters, the majority of the eye diseases or eye problems which the young generation has is myopia, or it is known as nearsightedness, right? That means the person will be able to see the object which is close to him, right? But he will not be able to see far away object. I am having nearsightedness. I am having myopia, right? Both of my eyes, right? Right? Clear? That is, unable to see far object. That is known as myopia or nearsightedness. You can easily understand nearsightedness means I can see near things. Right, that means let's draw it pictorially. What happens? This is your eye. Let's say this is your lens. This is the object P, right? The light rays falls like this, right? And this is your retina where you are supposed to have the image, but the image is formed before the retina. That is, the image is formed here. That is P dash. The image of P, that is object, is formed here, P dash. That means I will not be able to see the image, right? Clear, right? So that means I will not be able to see P correctly. So that means what has happened? The convergence of the lens has happened, and the convergence is happening before the focal point. So what should I do? I have to reduce the converging, right? Or I have to I have to allow the lens converge after this point, or it has to be done at focal point. You can term it again anyways. So that means this is your eye, right? So this was happening, this point was where the image was formed, so I have to shift it here. So what would I do? I will keep a concave lens before it, right? This is the same object, right? So light ray comes like this, right? It diverges, right? It diverges like this, and so that now it is, see, earlier the lens had to converge at p dash. Now it has been increased to what? This p dash image will be formed at for retina itself, right? Right, this is what happens in the case of myopia. Clear? Now the next one which you are going to deal with is hypermetropia, right? What is hypermetropia? Its another name is farsightedness. That means I can see far objects but I will not be able to see nearby objects, right? So that means if I draw the eye, this will be the lens. Let's say this is the object P, falls like this, right? And the converging happens after the focal point. This is the retina, but here is where the image P dash is formed, right? That means here the converging is not proper, right? So I have to do the converging proper, right? So how can I correct this problem? So this is the eye, this is our lens. You will keep a converging lens, that is known as convex lens, before it. So this is the object, so the light ray falls like this, so it is converged, right, like this, so that it means now here, right, the image will be formed at retina itself. Here the image is formed beyond retina, right? This is known as farsightedness. Youngsters will see, but it is less in the case of youngsters. Now the third one is called astigmatism. Astigmatism. Oh, I didn't write T, right? That means it is a problem of our cornea, right? That is, the cornea is not spherical in shape, right? This is a in-birth problem. That is, from the birth itself it will be there. It is not something which happens after a lot of age. It happens, it is usually there in the child form itself, right? So that is the cornea. Let us see. Cornea is actually like this, right? That is, you can imagine that the eyeball is like a spherical cavity with a cavity like this, right? Spherical surface with a cavity, and cornea is an oval shaped or a spherical device or a thing which fills this opening of this bowl, right? Spherical surface, right? This is what actually the cornea is. So cornea is not spherical shape, means the person who is having astigmatism will have blurred vision. That is, he will not be able to see the proper things, or that is, things will be seen but the vision will be very, very poor. That is, this is the eyeball, right? This is a lens, let's say. Now this is a shot which is having straight lines like this, right? The ear lines fall. Obviously the image will be formed at retina itself, but the image formed, see, the lines will be in this way. As you are not able to see them in a straight lines. Object is in straight line, the image formed is a curved one, right? And this is corrected by using cylindrical lenses, right? Cylindrical lenses of desired radius of curvature. That is, that will be of course told by your doctor, right? And this is usually done in the childhood itself, right? So cylindrical lenses, right? And the corrected vision will be what? Proper like this, right? Clear? The last section or the last type of eye defect is known as presbyopia. The fourth one, presbyopia. Now this is something which comes at old age for sure. Very rarely the old people don't have this, right? You would have seen that is, they have very thick lenses, right? And that means those lenses, or the correction of presbyopia is done by convex lenses. Keep that in mind. That is, in the old age, the ciliary muscles will lose their flexibility. Hence, the light which is entering in your eyes cannot be controlled by the properly, right? So you will have, when you go to the outside, high problem to your eyes. The entire light will be entering into you, right? Those type of sections, that is, suppose this is your eye, entire light will be falling for this entire retina, right? So it will be very difficult. So you use a convex lens so that each will be pointed at one single point, right? And it will be very thick, guys. Okay, so these are the type of defects.